I want to find an antiderivative for natural log of x. And it's not obvious that there is an antiderivative. I know that the derivative of natural log of x is 1 over x, but I can't think of a function whose derivative is equal to natural log of x. There's definitely no clear path of using a u substitution to try to attack this. Another technique I could try is integration by parts, but there's no product here, and integration by parts is the reverse of the product rule. But there's a hidden product, and it turns out that if you take advantage of that hidden product in this particular example, you can actually solve this. So I'm going to think of natural log of x as 1 times natural log of x. So I'm just sort of artificially thinking of this as a product of functions. And then if I think of this as f times g prime, or u dv, then the original function that I'm going to take the derivative of, I don't want to pick that to be 1, because the derivative of that would be 0. Now, that wouldn't be helpful. And then also, I don't know the antiderivative of natural log of x, so I can't pick that to be g prime. So that forces my hand. I've got to pick f equals natural log of x, and g prime equals 1. And I calculate f prime and g. I know f prime is 1 over x. G is going to be x, because the derivative of x is 1. So now integration by parts tells me that the integral of f g prime is equal to f times g, so x ln x, minus the integral of f prime g. 1 over x times x is just 1. And I can definitely find that integral. So I'm going to be able to solve this. To check my answer, I take the derivative of this. I'll have to use a product rule here, and it would be good for you to check and make sure that you do get back up to natural log of x. This method of taking some complex function that's by itself and thinking of it as 1 times that function, so you can try integration by parts. Turns out that that works also for finding antiderivatives of things like arctangent, arcsine, and arccosine.